What if I told you that most of what you learned about space in school was wrong? Not slightly wrong, not outdated by a technicality. Completely, confidently, beautifully wrong. Before you click away thinking you already know this stuff, hear me out. At least 3 of the 15 facts in this video are going to break something you have believed your entire life. One of them might even change the way you look at the night sky forever. So do yourself a quick favor before the truth starts landing. Tap that like button like it owes you money, hit subscribe so the universe keeps knocking on your door, and share this with the smartest person you know. Because by the end of this video, they might not be the smartest one in the room anymore. That might be you. Let's start with the moon. You have probably heard people talk about the dark side of the moon. There is a famous album named after it. Movies use it. Songs use it. It shows up in conspiracy theories and science. Fiction plots. Here's the problem. It does not exist. There's no permanently dark side of the moon. There's a far side, the side that always faces away from us, but that side gets just as much sunlight as the side we see. The moon spins slowly, once every 27 days or so, and that spin happens to match the time it takes to circle Earth. That is called tidal locking, and it is the reason we only ever see one face. It is not a coincidence, either. Over billions of years, Earth's gravity grabbed the moon and slowed its spin until the two rhythms locked together like a dance partner falling into step. But sunlight touches every part of the moon over the course of a month. Every crater, every mountain, every dusty plain. And here is the poetic twist. When we see a full moon blazing overhead, the far side is actually the dark side at that moment, turned fully away from the sun. 2 weeks later, when our side goes dark, the far side is bathed in daylight. The darkness rotates, just like everything else. When the Apollo 8 astronauts became the first humans to swing around the far side in 1968, they did not find darkness waiting for them. They found a sunlit landscape no human eye had ever seen, bright and cratered and strange, and for a few silent minutes they were cut off from all radio contact with Earth, the most alone any humans had ever been. So the next time someone mentions the dark side of the moon, you can smile, because you know the moon has no secrets when it comes to the sun. It only has secrets when it comes to us. Now stay with the moon for one more moment, because this next one gets almost everyone. Think back to school. Why does the moon have phases? Why does it go from a thin crescent to a full glowing circle and back again? If your answer is Earth's shadow falling on the moon, you are in the majority. Polls have found that most adults believe this, including plenty of people with university degrees. You are also wrong. Earth's shadow has nothing to do with the regular phases. The moon is always half lit by the sun, every single day, every single night. What changes is how much of that lit half we can see from where we stand. When the moon sits between us and the sun, the lit side faces away from us, and we see almost nothing. When Earth sits between the sun and the moon, we see the whole lit face. That is a full moon. It is a trick of perspective, not a shadow. Here's an easy way to prove it to yourself. Watch for the moon during the daytime. Yes, the moon is up in the daytime all the time. We just rarely notice it. When you spot a pale half moon hanging in a blue afternoon sky, ask yourself, where is Earth's shadow now? It is nowhere near the moon. Earth's shadow only touches the moon during a lunar eclipse when the 3 bodies line up perfectly, and that is a rare and special event. Everything else, every crescent, every half moon, every glowing coin in the sky, is just geometry. Beautiful, silent geometry happening above your head every single night, whether anyone is watching or not. Let's talk about the sun, because the lies about the sun are some of the biggest ones we carry around. Ask a child to draw the sun, and they will draw flames. Ask an adult what the sun is doing, and many will say burning. It feels right. It looks like fire. It warms your skin like fire. But the sun is not on fire. Fire is a chemical reaction. It needs oxygen, and space has essentially none. The sun is doing something far more violent and far more magnificent than burning. Deep in its core, under crushing pressure, hydrogen atoms are being squeezed together so hard that they fuse into helium. That is nuclear fusion, the same process inside a hydrogen bomb, except the sun does it continuously, converting millions of tons of matter into pure energy every single second. The core of the sun sits at around 15 million degrees, and here is a detail that will stay with you. The energy born in that core does not just zip straight out to your skin. Photons created at the center bounce and stagger through the dense interior, getting absorbed and re-emitted countless times, taking thousands, possibly tens of thousands of years just to reach the surface. Then, once they finally break free, they cross the entire gulf of space to Earth in a little over 8 minutes. The warmth on your face this afternoon began its journey before human civilization existed and finished it faster than your morning coffee order. The sun is not a campfire in the sky. It is a controlled nuclear explosion that has been holding itself together for 4.5 billion years, and it has enough fuel left to keep shining for about 5 billion more. And while we are on the sun, here is one that surprises almost everyone. What color is the sun? Yellow, right? Maybe orange at sunset? Wrong again. The sun is actually white. Pure, blazing white. If you could look at it from space, above our atmosphere, you would see a white star. Astronauts see it that way all the time. The yellow we know and love is created by our own air. Earth's atmosphere scatters the shorter, bluer wavelengths of sunlight far more than the longer, redder ones. And what is left leaning toward your eyes looks warm and golden. At sunrise and sunset, the light has to travel through even more atmosphere to reach you, so even more. Blue gets scattered away, and the sun turns orange or deep red. The sun has not changed at all. You're just watching it through a filter of air. In a way, every sunset you have ever admired was painted by the sky, not the sun. And this is not just trivia. A star's true color tells scientists exactly what kind of star it is, how hot it burns, and roughly how long it will live. Astronomers classify the sun based on that white light, not the yellow we see from the ground. Our yellow sun is an illusion painted by the sky itself, and we have been falling for it our entire lives. Now, quick check-in. If your brain is already buzzing, you are exactly where you need to be. And here's a little challenge. Drop a comment right now with your score so far. How many of these you actually knew? Zero shame, all curiosity. And if you are enjoying feeling your assumptions crack open one by one, that subscribe button is your ticket to more of this feeling. We chase the truth here, even when it is uncomfortable. Especially when it is uncomfortable. Here's a question that stumps almost everyone, and I mean everyone, from students to science teachers. Why do we have summer? If you think it is because Earth moves closer to the sun, you have just fallen for one of the most common space myths on the planet. And it is easy to see why. Closer to a fire means warmer, right? But Earth does not work that way. In fact, for those of us in the northern hemisphere, Earth is actually closest to the sun in early January, in the dead of winter, and farthest from the sun in early July, in the middle of summer. Read that again. We are nearest to the sun when it is freezing outside. If distance controlled our seasons, the whole planet would have summer at the same time, and January would be the hottest month of the year. Neither is true. The distance is not the story. The tilt is the story. Earth leans on its axis by about 23.5 degrees, and as it travels around the sun, that lean points one hemisphere toward the sunlight and the other away from it. When your half of the planet tilts toward the sun, the light hits you more directly, like a flashlight pointed straight at a wall, and the days stretch longer and everything warms up. That is summer. 6 months later, the tilt flips. Now your hemisphere leans away. The sunlight arrives at a slant, spreading the same energy over a wider area, like that flashlight pointed at an angle, and the days shrink and winter moves in. This is also why the seasons are flipped between the hemispheres. When it is summer in New York, it is winter in Sydney, because when one half of the planet leans toward the sun, the other half leans away. Seasons are not about how far you are from the fire. They are about the angle of the light touching your world. Let's shrink the scale for a moment and come back down to Earth, because this next myth is so famous that teachers still repeat it. The Great Wall of China is the only man-made object visible from space. You have heard it. I have heard it. It is printed in books, repeated in quizzes, and passed around like settled law. And it is simply not true. Astronauts have said it over and over again, and they have looked. From low Earth orbit, you cannot pick out the Great Wall with your bare eyes. A Chinese astronaut asked about it. After his flight, admitted he could not see it at all. Think about why. The wall is ancient and impressive, but it is narrow, only a few meters wide and built from stone and earth that blends almost perfectly into the surrounding landscape. Spotting it from orbit would be like trying to see a single strand of hair from across a football field. Here is the ironic part. You actually can see some human things from orbit. City lights glowing at night like spilled embers, major highways, cutting pale lines. Through deserts, airports, big bridges, even the Great Pyramids under the right conditions. So the one structure we built a legend around is nearly invisible, while 100 things nobody brags about shine clearly. The myth is more impressive than the view. Now let's head back out into deep space, where one of the most beautiful sights in the night sky has been fooling us for centuries. Picture a comet. You're imagining a bright head with a long, glowing tail streaming behind it as it races through the darkness, like a cosmic jet with a vapor trail. It seems obvious. An object moving fast should leave its tail behind, the way a boat leaves a wake, the way a runner's scarf streams out behind them. But comets do not care about our intuition. A comet's tail does not trail behind its motion at all. The tail always points away from the sun, no matter which direction the comet is traveling. The tail is made of gas and dust blasted off the comet's surface by sunlight and the solar wind, a constant stream of particles pouring out of the sun in every direction at hundreds of kilometers per second. That stream pushes the tail outward, away from the source, like wind blowing smoke off a chimney. So when a comet finishes its swing around the sun and heads back into the deep dark, it is actually traveling tail first. The tail leads, the comet follows. It looks completely wrong, and it is completely true. Many comets even grow two separate tails, one of pale dust curving gently, one of glowing, blue gas pointing in a straight line, and both of them aim away from the sun like compass needles. Every painting, every cartoon, every logo that shows a comet with its tail trailing behind its path is showing you something that has never once happened. The next time a bright comet makes the news, look at which way its tail points. You'll be able to find the sun in the sky just by following that line, even in a photo, even in the dark. Space has a habit of doing that. Let's look up again and find a star everyone thinks they know. The North Star. Polaris. Ask people why it is famous, and many will tell you it is the brightest star in the sky. It is not. Not even close. Polaris ranks somewhere around 50th in brightness. The actual champion is Sirius, the dog star, which outshines almost everything else in our night sky and sits low and glittering on winter evenings. So why does Polaris get all the glory? Because of where it sits, not how. It shines. Polaris happens to hover almost exactly above Earth's North Pole, which means that as our planet spins, Polaris barely moves. Every other star wheels across the sky through the night, rising and setting, but Polaris just hangs there, steady and patient within a single degree of true north. For thousands of years, travelers, sailors crossing black oceans, and people escaping to freedom followed that one fixed point to find their way. It earned its fame through loyalty, not brightness. And here is a bonus secret. Polaris is not even one star. It is a system of at least 3 stars dancing around each other, so far away that our eyes merge them into a single point of light. And one more twist. Polaris will not hold its title forever. Earth's axis wobbles slowly like a spinning top running down, tracing a full circle over about 26,000 years. When the pyramids were being built, the North Star was a completely different star, a faint one called Thuban. Thousands of years from now, the title will pass too. Brilliant, Vega. Even the most dependable star in our sky is only temporary. By now, you have probably noticed a theme. Your eyes lie, your textbooks simplify, and the universe does not care what you assumed. If this is hitting home, this is the perfect moment to send this video to that one friend who argues about space at every party. You know the one. Send it to them and watch them slowly realize half their favorite facts were fiction. And if you have not subscribed yet, think of it this way. Every video like this is a small upgrade to the way you see the universe. Hit the button. Future you, standing under the stars with real knowledge, will be grateful. Now let's visit the planets, starting with a question that sounds easy. Which planet is the hottest? Mercury, right? It is the closest to the sun, so it must be the hottest. It is the answer almost everyone gives, and it is wrong. Venus is the hottest planet in the solar system, and it is not a close race. Mercury, sitting right next to the sun, reaches around 430 degrees on its day side. Brutal, yes. But Venus sits at around 465 degrees, all day, all night, everywhere on the planet, from the equator to the poles. Hot enough to melt lead. Hot enough to melt zinc. So how does the second planet from the sun outcook the first? One word: atmosphere. Mercury has almost none, so its heat escapes straight back into space as soon as the sun sets. And its night side plunges to nearly minus 180 degrees. The same planet swings from oven to deep freezer every single day. Venus, on the other hand, is wrapped in a thick blanket of carbon dioxide, dozens of times denser than our air, with clouds made of sulfuric acid. Sunlight gets in, but the heat cannot get out. It is a runaway greenhouse effect, a planetary oven that sealed its own door shut millions of years ago. The pressure down there would feel like being nearly a kilometer underwater, and the air itself is so thick it behaves almost like a slow, hot ocean. When the Soviet Union sent its Venera landers down to the surface of Venus, the toughest spacecraft ever built for that mission were crushed and cooked and dead within about 2 hours. No machine we have ever made survives an afternoon there, and here is the haunting part. Scientists point at Venus as a warning. There is real evidence it may once have had shallow oceans, maybe even mild, pleasant weather for billions of years. Then something tipped, the sun brightened, the water steamed away, the greenhouse took over, and the planet crossed a point of no return. Venus is not just the hottest planet. It is a ghost story about what happens when a climate loses control. Here's another one that feels obvious until you think about it. Astronauts on the space station float because there is no gravity up there. Sounds reasonable. Completely false. Gravity at the space station's altitude is about 90% as strong as gravity down here on the ground. If gravity suddenly vanished at that height, the station would not drift gently in place. It would fly off into space in a straight line, tangent to its orbit, and never come back. So why do astronauts float? Because they are falling constantly. The space station is moving sideways so fast, around 28,000 kilometers per hour, that as it falls toward Earth, the curve of the planet falls away beneath it at exactly the same rate. It never hits the ground. It falls forever in a perfect circle, and the astronauts inside are falling right along with it, falling at the same speed as their ship, so nothing presses them against the floor. That is what weightlessness really is. Not the absence of gravity, but the experience of endless free fall. Orbit is just falling with style. It is the same feeling you get for a split second when an elevator drops, or a roller coaster crests a hill and your stomach rises into your chest. Except astronauts get to live inside that feeling for months at a time. Gravity never left. It is holding the entire station in its grip every second of every day, keeping it from escaping into the dark. Weightlessness is not freedom from gravity. It is surrender to it. Now, for a fact that sounds like it should be illegal, Jupiter does not actually orbit the Sun. Stay with me, because this one is real. When two objects pull on each other with gravity, they do not move around one another in a simple circle. Both of them orbit a shared balance point called the barycenter, like two people holding hands and spinning, each pulling the other around. For most planets, that balance point sits deep inside the Sun because the Sun is so enormously massive that it barely notices them. Earth tugs on the Sun and the Sun shrugs. But Jupiter is not most planets. Jupiter is so huge, more than twice as massive as every other planet combined, that it actually drags the balance point outside the Sun's surface to a spot in empty space just beyond the Sun's edge. The Sun and Jupiter both waltz around that invisible point. In a very real sense, the Sun wobbles because of Jupiter, swinging back and forth over the giant planet's 12-year orbit. And this is not just trivia to impress your friends at dinner. This exact wobble is one of the main ways astronomers discover planets around distant stars. They cannot see the planets themselves, so they watch a star tremble ever so slightly, swaying toward us and away, and they realize something invisible is pulling on it. Hundreds of worlds have been found this way, worlds we have never seen directly, revealed only by the sway of their sun. Jupiter taught us that even the Sun can be moved, and that lesson handed us an entire galaxy full of planets. And while we are here, let us retire one more piece of bad trivia. You may have heard that Jupiter is a failed star, that it almost ignited. It did not. It was never even close. A star needs around 80 times Jupiter's mass before the pressure in its core can light the fires of fusion. Jupiter is not a failed star. It is simply the most successful planet, so dominant that it reshaped the entire early solar system, flinging some worlds into the Sun and throwing others out into the dark. It is not a failure. It is the boss. Time for another check, because the next few facts are the ones that keep astronomers up at night. If you are still here, you're not just a casual viewer. You are the kind of person who stays for the deep stuff. And honestly, that is rare. So here is a different kind of invitation. Subscribe, not because I asked, but because your curiosity clearly refuses to sit still. Feed it. And while you're down there, like the video so it reaches one more person who thinks the moon has a dark side, somewhere out there, that person needs you. Let's go big now, as big as it gets. The Big Bang. Say those words and most people picture an explosion. A cosmic firework, matter blasting outward from a center point into empty space, like a bomb going off in the void. Every part of that picture is wrong. The Big Bang was not an explosion in space. It was an expansion of space itself. There was no empty void waiting to be filled, no outside, no edge, no center. Every point in the universe was the bang. Wherever you are sitting right now, the Big Bang happened there and here and everywhere. Space itself stretched, and it is still stretching today. In the first fraction of a second, the universe underwent something called cosmic inflation, swelling from smaller than an atom to something vast almost instantly, not by hurling matter through space, but by growing the space between everything. Imagine drawing dots on a deflated balloon and then blowing it up. The dots do not move across the balloon. The balloon itself stretches, and every dot drifts away from every other dot, and from the perspective of any single dot, all the others are fleeing. That is our universe. Galaxies are not flying apart through space like shrapnel. The space between them is growing, and we can still hear the echo of that first moment. The entire sky glows faintly with ancient radiation called the cosmic microwave background, the afterglow of the young universe, a whisper of heat still washing over us nearly 14 billion years later. Old televisions, the ones with static between channels, caught a tiny fraction of that static from the Big Bang itself. When you look at the night sky, you are not looking at the aftermath of an explosion. You are standing inside, An expansion that has been running since the beginning of time, and it is still going right now between the stars and inside your own sky. That expansion leads to one of the strangest truths in all of science. You have heard that nothing can travel faster than light. 300,000 kilometers per second, the ultimate speed limit. And it is true, mostly. Nothing can move through space faster than light. But space itself is under no such obligation. Space can expand at any speed it likes, and it does. There are galaxies so far away from us that the space between us and them is stretching faster than light can cross it. Their light is racing toward us with everything it has every single second, and it will never, ever arrive. Imagine running up a downward escalator that keeps speeding up until it moves faster than you can ever run. Those galaxies are sailing beyond a horizon we can never cross, carried away by the growth of space itself. This is why the observable universe is about 3 billion light years across, even though the universe is only about 14 billion years old. The light traveled, but the road stretched faster than the journey. And here is the part that quietly breaks your heart. Every year, more galaxies slip silently across that horizon, fading from our possible sky forever. Future astronomers, on some distant world billions of years from now, may look up and see a sky almost empty of galaxies, with no way to ever know what was lost. The universe is not just expanding. It is quietly taking its most distant treasures out of our reach, one galaxy at a time, and no technology we will ever build can chase them down. Let's visit Saturn, the jewel of the solar system, because it has been keeping a secret. Those magnificent rings, the ones that make Saturn the most beautiful object in any telescope, feel eternal. Surely they formed alongside the planet 4.5 billion years ago. That is what scientists assumed for centuries. And honestly, it is what your eyes want to believe. Then the Cassini spacecraft arrived and everything changed. In its final mission, before its planned dive into the planet, Cassini threaded the gap between Saturn and its rings again and again, measuring their mass with exquisite precision. And the answer shocked everyone. The rings are far less massive than expected and far too clean. If they were billions of years old, they should be darkened and polluted by endless micrometeorite dust, like fresh snow slowly turning to city slush. Instead, they are bright, fresh, almost pure water ice. The conclusion is stunning. Saturn's rings may be only 10 to 100 million years old. That sounds ancient until you realize what it means. When dinosaurs walked the Earth, Saturn may have had no rings at all, or the rings may have been brand new, still forming from a shattered moon or a comet torn apart by Saturn's gravity, ground into a billion pieces of ice and spread into a gleaming disk. And the rings are temporary in the other direction too. Cassini found they are slowly raining down onto the planet in what scientists call ring rain, losing material every single second. In a few 100 million years, Saturn may be bare again, just another gas giant, and whatever beings look at it, then will have no idea what they missed. There is something quietly moving about that. The rings do not care that we can see them. They would gleam whether or not anyone was watching. But we are watching in this tiny sliver of cosmic time when they happen to exist. We happen to live in the brief, cosmic moment when the most beautiful sight in the solar system exists. Think about that the next time you see a picture of it. You were born in the era of the rings. Now the final fact, and I saved the most misunderstood object in the universe for last: black holes. Ask anyone what a black hole does and they will tell you it sucks everything in. A cosmic vacuum cleaner roaming space and devouring anything unlucky enough to wander past. This image is everywhere, in movies and headlines and nightmares. And it is wrong in a way that matters. Black holes do not suck. They have gravity, the same ordinary gravity everything else has. If our sun were magically replaced by a black hole of the exact same mass, Earth would not get pulled in. We would not spiral into the darkness. We would simply keep orbiting exactly as we do now, forever. We would all freeze, of course, without the sunlight, but the orbit would not change one bit. A black hole only becomes dangerous if you get extremely close, because its mass is crushed into such a tiny point that gravity nearby becomes ferociously intense. Cross the boundary called the event a horizon, and there's no way back, not even for light, which is exactly why they are black. And it gets stranger. Near a black hole, gravity is so extreme that time itself slows down. An hour close to a giant black hole could be years for everyone farther away. If you fell toward one, the difference in gravity between your head and your feet would stretch you into a long, thin thread. Scientists actually call it spaghettification, and yes, that is the real official word. But from a safe distance, a black hole is just mass, obeying the same rules as everything else in the cosmos. Black holes are not monsters hunting through space. Most of them sit quietly in the dark, barely touching anything. In fact, the giants at the centers of galaxies, including the one at the heart of our own Milky Way, may be the anchors that hold entire galaxies together. The thing we fear most in the universe might be the thing quietly keeping our home galaxy in one piece. And that brings us to the deepest truth of all, the one hiding underneath everything else in this video. When you look up at the night sky, nothing you see is happening now. Light takes time to travel. The moon's light is more than a second old. The sun's light left its surface 8 minutes ago. The nearest star system shows you light from 4 years back. The Andromeda Galaxy shines at you across 2.5 million years, meaning the light hitting your eyes tonight left Andromeda before our species even existed. You are not watching the universe, you're watching its memory. Every star in your sky is a message from the past, and some of those stars may not even exist anymore. Their light is simply still on its way to you, crossing the dark long after its source may have died. You have never once seen the present moment of anything beyond your own skin. Even the person sitting next to you reaches your eyes a fraction of a heartbeat late. Every glance you have ever taken at everything is a glance into history. And here is the part that should stay with you long after this video ends. Science is not a list of facts carved in stone. It is a living correction of our own beautiful mistakes. The dark side, the burning sun, the eternal rings. Every wrong idea was a stepping stone to a truer one, and some of what I told you today will be corrected someday too by someone with a better telescope, a sharper mind, or a braver question. That is not a failure of science. That is the whole point of it. The universe does not hand us its secrets. It waits for us to become curious enough, humble enough, and stubborn enough to earn them. Tonight you earned 15 of them, so keep looking up. Keep asking questions. And never trust the sky to be as simple as it looks, because it never is, and that is exactly what makes it worth watching. Thank you for staying until the very end, because that puts you in rare company. Most people click away long before the final fact, but you're clearly built differently. If this video changed even one thing you believed, let me know in the comments which fact broke you. And one last thing before you go. Subscribe, turn on notifications, and share this video with someone who still thinks the sun is on fire. The truth travels the same way light does. It just needs someone to carry it. Tonight, that someone is you. I will see you in the next one, somewhere out there in the beautiful, misunderstood dark.